identical, and they did the first one for you there. Step 1 is actually identical to step 1 from yesterday, which was where we took just a few minutes to decide, are we using so, ka, or toa to solve the problem. So that is step 1 yesterday and today. So when we look at number 1 here, what I'm seeing is they chose cosine. You see that? And I mean, they use a question mark here, which is fine, but really the big kids are pretty much going to call that question mark a theta. And what they don't tell you about that problem is, well, they don't tell you theta for one, and that's ultimately our goal, is to find that missing angle measure, but they don't necessarily come about telling you why they chose cosine. Can anybody tell me why they chose the cosine ratio for this problem? Yeah, sure is. That's absolutely correct. When you look at theta, they're giving you the adjacent side right here, because this 6 is right next to theta there. And they're giving you the hypotenuse, and we decided that the hypotenuse was all the way across from that right angle there. So for that reason, they set up the cosine ratio. I also don't like that they just jumped right into this. I'm going to add a little bit more work. So how did they get from that to that? Well, they did this. Let me show you. So they took a second, and they're like, okay, well, cosine of theta is always equal to the ratio of your adjacent side, which we decided was 6, over our hypotenuse, which we decided was 8. Now, make no bones about it, we are using our crazy algebra skills to try to solve for this variable right here. We're trying to solve for that angle measure. We're trying to figure out what theta is, right? Well, back in the day, I used to see students swinging through. This was kind of funny and adorable all at the same time. They would try to, like, divide both sides. I'm going to write something down. Don't write it because it's wrong. They would go like this. Because they're like, oh, 2 things next to each other just means multiplying, so I'm just going to divide both sides by cos. And I was like, what? I appreciated, however, the fact that they were trying to use an inverse operation to isolate a variable. Not a bad idea. It's just like, how do you divide by a cos? It's like trying to divide 2 by a square root symbol, because it's just a function. Like, how do you even do that? You can't. So it brought up the conversation a few years back, well, how do you get rid of that cos then? Like, what is the idea? And remember, I just used a phrase. The phrase I used was inverse operation. I appreciated that my students wanted to use an inverse operation to get rid of what they thought was multiplication. But actually, to get rid of this cos, we have to take the inverse of both sides. So what we're actually going to do here is, shrink this down a little bit. What we're actually going to do here is multiply both sides by the inverse. We're going to use an inverse operation. It's just we write it differently in trig. The inverse of cosine is written cosine to the negative first power. You might remember from Algebra 2, anything raised to the negative first power kind of denotes an inverse. Okay? So, when you multiply things by their inverses, they turn into the identity. So, cosine inverse knocks out cosine. That's nice. And then theta's theta's by itself. However, what we do to one side of an equal sign, we have to do to the other. So that's how they got that. Sorry, guys. I got a tickle in my throat. And I left my water bottle in the math office. Super fun. Good, thanks. Okie dokes. Not done yet, though. This is where we let our calculator do the rest of the work. Making sure you're in degree mode. You're going to go ahead and press second cosine. Isabella just reminded me of something important. I'm glad I did that. Second cosine, and then we're just going to type in 6 divided by 8. 41.4 is the answer you should get, and that's the answer they got too. questions about that? Is it okay if I talk about your phone? Because it's awesome. Okay. Your calculator, you know how some of you have phones. You can't use a phone on a test, but let's say, you forgot your calculator. You want to use your phone calculator today in class. You guys might know this already, but if you turn it on its side, you get more functions. So like sine, cosine, tangent, they are on there. And you could use your calculator on your phone, just flip it sideways. So if you're desperate, that's nice. So I just wanted to point that out. All right, let's try it again. Just make sure we nail it down. Try it a couple more times. Okay, so once again, ooh, they're giving me options this time. That is fancy. I'm going to try to figure out what that question mark is. I like to call that question mark theta. And honestly, they gave me all three sides. So I could use any one of my three trig ratios to set this problem up to solve for x or solve for theta. I don't know, what do you guys want to do? Sin? Great. Let's do that. So we're going to do the sine of our angle. We call it theta. It's the ratio of the opposite side to the hypotenuse. So if I look opposite of my theta all the way across the triangle, that's 14. And my hypotenuse is always across from my right angle. It's also my longest side, which is actually going to have to be the biggest number in the problem, which 50 is the biggest number in the problem. My hypotenuse is 50. The idea is I want to get that theta by itself, right? So I would do sine inverse on this side. That takes out that. And then to figure out what theta is, I have to do sine inverse of 14 over 50. Because what I do to one side of an equal sign, I must do to the other. So then I throw that in my calculator. Second sine of 14 divided by 50. I got about 16.26. It says round to the nearest degree. I just noticed that in the direction, so let's stick with that. We're looking at about 16 degrees. Okay, just for fun, and I think you have to do this a little later. Why won't that erase? Well, that's annoying. We found that this angle right here is 16 degrees. How would you find, like, that angle right there? Remember the question I asked you to kick off today's lesson? What do you think, Zach?
So you do 180 minus 90 minus 60.
Yeah, that is definitely an option. You're always subtracting 90, right? 180 minus 90, because these are all right triangles. This stuff only works really on right triangles, by the way. How do you do this stuff on non-right angles? We do at the very end of the semester. We have to use, like, law of sines, law of cosines. I digress. You're always subtracting 90 from 180, right?
Pardon the interruption. Attention all students who signed up to ride the student bus.
So with that, what I was trying to get at, Zach, we have options. Because you're always going to be subtracting that 90, you could save a step. 180 minus 90 is always going to be 90, right? Yeah. So in saving a step, what I'm trying to say is this angle here and this angle here are always going to add up to what? 90, yeah. So you could just do 90 minus the angle you just found, and that's, instead of doing 180 minus 90 and then minus your angle, you could definitely do that. So 90 minus 16, 90 minus 10, chunking it out to 80, come back 6 more, we're at 74 degrees. So that's nice. Let's do one more together, and I'll let 4 be independent practice. So once again, we get to pick. What do you guys want to pick? You want to do tangent this time? Wow. Sounds like a martial arts thing. I don't know. I don't know martial arts. I wish I did. Okay. Anyway, tangent of our angle is the opposite side. So opposite of our theta is 16. So that's 16. And then our adjacent side is next to theta. Can't be the hypotenuse. It's going to be 30. So our ratio that we have to write next to this is 16 over 30. Get out of here. And then I would inverse tan on both sides. So tan inverse over here, tan inverse over here. And then we let our calculator do some work. So we got second tan. I love how you guys picked a different ratio. You're like go-getters. I have a class of doers. That's nice. Okay, so theta is 28 degrees this time around. Okay, why don't you go ahead and find that question mark number 4 for me. We'll make sure you can do this. So this guy here ends up being, where'd it go? Theta is about 53 degrees for that problem. Does anybody not get that and not know what they did wrong? 53 degrees. Right there. You good? All right, awesome. Okay, so what you're working on right now, and so for tonight's assignment,